From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and concerned citizens making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Melathopoulos, Assistant Professor in Pollinator Health in the Department of Horticulture. Maybe you're listening to this episode in your garden, maybe you're on your farm or you're on a woodlot, maybe you're in your apartment, and you're scratching your head wondering, how is this area for bees? How is the nesting resources, the floral resources? Is there a lot of pesticide use? How can you get an answer to that question? Today's guest leads a team that's developed a tool that allows you to answer that question. Christina Groziner is a professor of entomology and the director for the Center for Pollinator Research at Penn State University, and her team have come up with a new app called BeeScape. It's a really cool tool that integrates data layers that are already existing on pesticide use, nesting habitat for pollinators, and also floral resources for pollinators. It also allows you, as users of the app, to input your own information on how your, for example, bee colonies are doing in that area. To help us learn more about BeeScape, I've invited a guest host on the show, Emily Carlson. She's a PhD student in my lab, but also in the apiculture Sagili lab here at Oregon State University. Emily's research is focusing on the patterns of exposure of both honeybees and native bees to pesticides in different agricultural landscapes in Oregon. So without further ado, here's Emily and Dr. Christina Groziner this week on Pollination.
So BeeScape was released in the spring of 2019 and just went through a big expansion. Can you describe to us what BeeScape is, what it does, and why it's needed?
Sure. So I'll start actually with why it's needed and then kind of tell you what you can expect to get from using BeeScape. So we know that a lot of the factors that are causing honeybee colony deaths and also wild bee population decreases are things that are happening at the landscape scale. So it's loss of flowering plants that the bees need for nutrition, and it's increased exposure to insecticides and loss of nesting habitat for wild bees. But because bees are sort of covering long distances when they forage, especially for honeybees, these factors can be acting at sort of really large scales in the landscape, and they're beyond the scales that a beekeeper or even a grower in some cases can really control. And so we wanted to have some sort of tool that beekeepers and growers and land managers could use to really understand the resources and risks that bees might be experiencing in the landscape. And trying to find a way to present this in an easy, visually accessible way that could work at different sites across the U.S. was kind of challenging. And so after much discussion among our group of collaborators, we developed BeeScape. So for BeeScape, it is an online platform where you can go and find your site of interest and drop a pin on that site, and then get these landscape quality scores at a 3 or a 5 kilometer radius around your site. And for landscape quality, what we're giving people is seasonal forage quality, so forage quality in the spring, summer, and fall, wild bee nesting habitat, and then insecticide toxic load. And these are estimates that are based on a number of landscape indices that people in our group have developed. So the forage and the nesting quality indices were developed by Eric Lonsdorf and his collaborators, and they actually developed this a couple of years ago and published a couple of papers on this. And the insecticide toxic load was developed by Maggie Douglas, who's an assistant professor at Dickinson College. And this is basically calculated by taking the average pesticide use profile for a particular crop in a particular state, and then converting that into a toxic score.
Got it. So just to make sure I'm understanding you. So you take, to understand pesticide risk, you're taking what would be considered an industry standard and then averaging that for the landscape surrounding the potential apiary location.
Yeah, so it's actually coming from a number of different government databases. So the USGS has a pesticide survey, which is essentially asking growers what insecticides and pesticides they're using on their crops. And that will vary for a particular crop and in a particular state. So somebody who has pumpkins in one state might be using different types of insecticides than somebody who's using pumpkins in a different state. So we get that information, which is coming from growers, and again, it's aggregated through the USGS. And then we take the amounts, the quantities of those insecticides and the types of insecticides, and we convert them into toxic scores using the EPA toxicity database. And then that gets aggregated for all of the insecticides that would be predicted to be used for that crop in that state. And so then when you're dropping your pin in BeeScape and aggregating in this 3-kilometer radius, it's basically asking, which crops are being grown in that 3-kilometer radius and sort of summarizing across those. We actually have a distance weighting function in these indices as well. So things that are closer to the site where you're dropping your pin are weighted higher than things that are further away.
Got it. So it sounds like from this work you have examined pesticides across the United States. What are some of the general trends around pesticide risk in the U.S. that have come to light using BeeScape?
So we published a paper on this in January of this year, so January 2020, and this was looking at the overall trends in insecticide use from 1997 to 2012, and essentially sort of seeing how these have changed over time. And so what we found was that the overall toxic load, and so this is again sort of if all the insecticides that were being used on a particular landscape came in contact with the bee, what is the overall number of bees that would die from that? So that's how we're calculating the toxic load. So we found that the overall toxic load across the whole U.S. Has increased by 9-fold over this period from 1997 to 2012. But there's a lot of geographic variation in that toxic load. So there's some regions, especially in the heartland, where we see a much greater increase. So in that area, it was an increase of over 120-fold in terms of the overall oral toxicity. And this does not seem to be coming from an increase in the amount of land that's being used for agriculture or the amount of land where pesticides are being applied, but rather the types of pesticides that are being applied are overall more toxic. And so that's contributing to this overall increase. And what we found was that at this sort of national scale, the major drivers of this increase was seed treatments in corn and soy field crops. And so we know that these crops have seed treatments that include neonicotinoids. And neonicotinoids have very high toxicity to insects, which makes them great insecticides, but also increases the risk that bees would experience in these areas.
Got it. So even though the amount of land is staying the same that pesticides are being applied to, and the actual pounds per acre applied is going down,
yeah,
correct?
Yep.
The insecticide toxic load is going up due to a change in active ingredient that's becoming more common.
Exactly. So kind of, again, depending on how you would look at this, you would think that there's less total weight of pesticides being applied, so that looks great, right? But when you actually look at it in terms of toxicity, there's an increase, and that's because of the types of chemistry of the insecticides being used, and in particular, the neonicotinoids are the main drivers of this increase in toxicity.
Got it. And those are products that you just come on the seeds that you don't even spray on a field. Just when you buy it, they automatically are there.
Yes, and there's actually Maggie Douglas and some of her collaborators from the USDA ERS published another study where they were looking at these USGS pesticide surveys in more detail. And an interesting thing that they found was that the growers were not able to consistently identify the fact that they had neonicotinoids on these seeds that they were purchasing, right? So what's happening is that, almost all the seeds that you can buy for these field crops are already coated with neonics, and then growers are just buying what is available to them. And so they're not actually making choices about, these particular insecticides. They're just purchasing them. And so, I think, for us, this is one of the main things that we would be concerned with is that, of course, insecticides are really important for agricultural production, but growers should be able to choose which pesticides they're using and choose them in response to a particular pest threat, and not just, have to use them because that's the only thing that they can actually purchase.
Got it. Yeah, that's super interesting. I am curious why. So you said the survey goes up until 2012. Is there no more data available after that? Like, why the 2012 endpoint?
So that was when the sort of most recent and comprehensive information was available for this particular study. But one of the concerning things, and this is again highlighted in the other study from Maggie Douglas, is that the seed treatments are no longer being included in these surveys, and part of it is because it's difficult to collect that information if the growers don't actually know what's on their seeds and can provide that information. And so again, this is one of these issues, is that if sort of a major source of insecticide toxicity is coming from these seed treatments, and we're no longer tracking those treatments, then we lose a lot of information.
Yeah, I can see why this makes something like BeeScape really necessary for understanding pesticide risk and floral resources, because you have all of these factors happening in the landscape that any one individual landowner couldn't necessarily be aware of.
Yeah, and again, because we're able to kind of aggregate at this landscape scale, I mean, you might know what's going on in your specific area and what you're doing, but, being able to understand what's going on, at a 5-kilometer radius, again, depending on what kind of landscape you're in, can be really challenging. So in Pennsylvania, for example, we have fairly small farms, right? And so bees could be going across multiple farms when they're foraging, and so to be able to understand what they're experiencing, we really need to have something like BeeScape to help beekeepers and others.
Awesome. So let's look at a particular system in general. So counties in Oregon. Like what can BeeScape tell us about pesticide exposure in our states? As we in Oregon agriculture, we have a lot of small farms and a lot of specialty crops that we produce. So I'm curious to hear you speak a little bit about that.
Yeah, so if at this point, so we have made BeeScape national as of a couple of weeks ago. So anyone can really go into their site and explore what's going on in their surrounding landscapes. And BeeScape allows you to not only get these scores that I was telling you about before, but it also gives you general estimates about whether these scores are low, medium, or high, sort of relative to the sort of overall range of scores that we get. And you can also overlay the cropland data layer, so you can see which crops should be growing in your area. And overall, what we find is that, of course, if you have sort of natural landscape that doesn't have any agriculture in it, then you have high forage, high nesting habitat, and low pesticide scores. And then depending on what kinds of crops you have in your region, that again will sort of change your pesticide score and then your forage score. And so while we were talking earlier about sort of these field crops like corn and soy have very high insecticide toxic load predictions because they use a lot of seed treatments. Some of these specialty crops, especially sort of the fruit and tree nut crops, will have also high pesticide scores because they tend to require a lot of pesticides in order to get a good yield. But one thing to keep in mind, before you sort of look at BeeScape and then potentially get upset with some grower that's near you because you think that they might be increasing, the overall insecticide scores, is that, these indices that we're developing are basically just a guideline for people to use, right? So we're calculating the insecticide scores based on what is used on average for that crop in that state, which means that we're not able to necessarily capture what might be going on in a particular farm. And also the way that it's calculated is assuming that every single drop of pesticide that's being applied actually contacts a bee, which of course we know that is not true and that exposure rates can vary a lot. And so if insecticides are being applied before bloom, for example, or well after bloom, they're not going to affect the bees. And so the overall contact is expected to be lower. That being said, we also didn't capture other things that might be going on. So we're not able to look at potential sublethal effects that might be happening to bees that are exposed to these insecticides. We're not looking at synergistic effects. So we know that fungicides will interact with some of these insecticides and increase the overall toxicity to bees, but we don't include that in our index at all. And we also don't account for accumulation, right? So some of these pesticides, particularly the neonicotinoids, will accumulate in the soil and so sort of increase over years. And again, we don't include that in this index. So basically what these indices give you is sort of a general rule of thumb about what could be going on in your landscapes given the types of crops that are being grown.
Got it. And they also, and in doing that, you're also able to kind of compare to the rest of the United States with your floral score and your pesticide score, right? So yeah. How might that help you understand? Well, I guess that's a silly question. Sorry.
Well, yeah. So again, this sort of, it can help you because when you're dropping your pin, you get, again, these numbers for your different indices, which can be a little bit hard to interpret. But again, you can sort of see what range they're in. So if this is considered like low forage or high forage, that can help you. And the way we sort of originally designed BeeScape was the thought that beekeepers might have some choices over where they could be putting their colonies. And so you can compare across sites as well and see which ones might have better forage scores or better predicted forage scores or lower pesticide scores, and then that can help you choose where to put your apiaries.
This seems like an amazing tool. And we talked a little bit about the assumptions behind the dashboard, but how could BeeScape scores be over or underestimating the pesticide risk to bees on the ground?
Well, so basically with these indices, we wanted to provide sort of a generalizable score for quality in terms of forage quality, nesting quality, and then also insecticide use that could be used across, a lot of different kinds of types of land use patterns across the United States, right? So whenever you sort of generalize like that, it means that it may not be really accurate for your specific location. And so the forest and nesting scores were created based on expert opinion. So essentially asking researchers how they would score particular land use patterns, again, for seasonal forage or for nesting. And then the insecticide score was again calculated using sort of the average quantities and types of insecticides that are used for a particular crop in a particular area. And so again, this is sort of the starting point for understanding what might be going on in your landscape. But one of the things that we're doing actively in my lab and also other labs is trying to take these scores and integrate across them and see how they predict bee health outcomes. So the hope is that sort of in the future, rather than sort of getting each score individually, that tells you something about what we predict for forage and nesting and insecticide quality in the landscape, we could actually say how all of these things together would integrate to predict, honeybee mortality at this site over the winter, for example.
Wow, that's really cool. So I just wanted to follow up about the floral resource score. So that's based off of an expert opinion. So can you tell me a little bit more about that and what that looks like?
Yeah, so this was developed by Eric Lonsdorf, and so it's often called the Lonsdorf Index, which Eric really does not enjoy having to call that. But essentially, there was a panel of experts that were given these different land use categories and asked to provide sort of their opinion on how well this particular land use category would provide spring forage for bees, for example, or nesting quality for wild bees. And then that information was aggregated across all those experts to create this score. And this is one of the things that we've been talking with Eric and Sarah Gosley, who's our collaborator from the USDA ARS, about how we might try to improve this forage quality score. And there's a couple of things that we've been thinking about doing. So for example, as we all know, especially this summer, depending on the weather, your plants will be growing better or worse, right? And so you can actually assess vegetative growth through, the NDVI index that's again available across the U.S. So maybe there would be ways to modify the forage quality score based on how well vegetation is actually growing in that particular year, for example. The index was developed using the cropland data layer, but there's other databases for land use patterns that are more detailed, and especially for different kinds of landscapes, so not just agricultural landscapes. So incorporating some of that might also improve the predictive quality of the forage resource score. And one of the things we've been working with Anthony Robinson, who's a professor at Penn State, who did a survey of Pennsylvania beekeepers and sort of asking them, how they felt about BeeScape and the information that they're getting from BeeScape. And one of the interesting things was that they felt that based on their personal experience, they didn't think that the forage quality score was reflecting what they thought the forage quality was in their particular landscape. So that's also something that we would like to follow up with them on and try to understand, what information are they using to decide whether or not an area has good floral resources. And maybe it's something, different from what the experts that were originally surveyed are thinking about. And so can we use that information again to potentially improve the forage quality score?
Cool. Could you give like an example just of like what a high quality forage habitat might be showing up in this? Like if I see really high quality forage, like what kind of land use might that be?
So in the springtime, the forests are considered to be really high quality, and this is because of sort of spring blooming trees. And this is also work that's coming out of a number of labs, and some work that a former postdoc in my lab, Doug Sponsor, did. Looking at the pollen that bees are bringing in throughout the season, and in the springtime, they're using these flowering trees. So anywhere where you can have those trees should improve your overall scores. And then as you go sort of into the summer and fall, then there's more of these herbaceous plants. And so, things would, like meadows, for example, would be providing a lot of these resources. But cool. Essentially, again, a good rule of thumb is the more natural habitat that you have and the more diverse and edge habitat that you have, the better your scores will be.
Awesome. So that leads into our next question really well. How are beekeepers, land managers, and regulators using this tool? And what potential might it have for researchers as well?
So one of the interesting things was when we first sort of released BeeScape, the people that were most excited about it were the researchers. So we had a lot of people contacting us asking, how they could sort of get access to the pipelines that we were using to develop these scores and to use the scores for their own studies. And again, this was sort of part of our rationale for developing this was because we really wanted to have a way to in our studies understand how these land use patterns were affecting different bee health metrics, and trying to go beyond sort of simply saying, well, what percentage of land is agriculture and what percentage is natural lands, and having sort of these more detailed assessments. And so that seems to be the main interest from researchers, is just having sort of more biologically and ecologically relevant ways of assessing the landscape and using that for these modeling analyses. For beekeepers, and we sort of originally thought about this in this way that beekeepers could look at different sites and decide which one might be best for housing their apiary. But a lot of beekeepers don't necessarily have options about where they can place their bees. So for them, what they can do with BeeScape is see, again, how these scores sort of stack up in their particular landscape. And if it seems like there's low spring forage quality, then that might be something to consider in terms of when you might want to do supplementary feeding of your bees, or when you might want to extract honey, for example. Land managers, we've talked to a couple of people who work in sort of departments of natural resources and conservation, and they really like BeeScape because, again, they can sort of see where predictions for floral resource quality would be high or low for a particular season. And so if they're trying to do habitat restoration or mitigation, then they would know, okay, well, we need to add more plants that can provide flowers in the fall, for example, because this area is predicted to have low fall floral resources. And also this, if you're going to be installing habitat for bees, it's not easy and it can be quite expensive. And so maybe you want to install it in an area where there would be less pesticide exposure, for example. And so mostly from what we've heard from people, what they really like about BeeScape is that it's relatively easy to use. And so, you can just sort of drop your pins across your sites and then see these scores and rank things according to these scores. So it sort of makes this complex information, fairly accessible for different people.
That's great. So it's really a tool that has a lot of applications for different types of people, and can help people strategize how best to do a habitat restoration, or what areas might be prime for putting in an apiary. And therefore, it sounds like it has a lot of diverse usage.
Yeah, and that was what we were hoping, was that, it's obviously our sort of target initially was beekeepers, but we're hoping that it could be used for a lot of different kinds of needs.
Great. So then what's next for BeeScape? Like, it's this great tool, it's doing all these wonderful things. What might we expect in the future?
So we have a lot of plans for things that we would like to do to improve BeeScape. So like I mentioned before, we are working with a number of different data sets on honeybee and wild bee health, and trying to see how these different landscape scores correlate with those health metrics, so that we can incorporate that into BeeScape. So instead of just getting these scores, we can have a prediction for how well your bees will do. And actually, one of the first studies that we did with this was looking at winter honeybee colony mortality using data that we had from the Pennsylvania State beekeepers. And this was work that was led by Martina Kalovi, who's a postdoc with Sarah Gosley. And one of the interesting things that we found was that it was really weather that was a major predictor for mortality and not so much these landscape indices. And so that, of course, is always frustrating, but we created a new tool, which you can also find on the BeeScape website, which is called Bee Winterwise. And it basically allows beekeepers, and at this point, this tool is only working in Pennsylvania because that's where all of our data was coming from. But you can drop a pin and sort of see whether or not your site is too warm or too cool for sort of an optimal overwintering outcome. And again, that can kind of help beekeepers prepare and maybe adjust their management for their colonies. But we're hoping, so BeeScape itself has there's a ability for beekeepers to register and provide information on their winter survival for their colonies. So we're hoping that as we get more information across more states, then we can expand this out to other states as well. So in addition to kind of using it for really predicting these bee health outcomes, we do have plans again to try to improve the forage index scores, or the predictive value of the forage index scores, by including some of this other information. We've been working with Vikas Khanna, who's a professor at University of Pittsburgh, who's developed an economic map of pollination services across the U.S. that also can be downscaled to this, to sort of the level of resolution that we need for BeeScape. So if we can incorporate those indices into BeeScape, then you can see sort of what the economic benefit of bee pollination is in your specific area. And in the future, we would like to sort of expand the BeeScape to have sort of the ability to look at different scales of sites. So right now we have 3 and 5 kilometer scales, but we'd like to go to a smaller scale that can be helpful again for planning on sort of a very local level. And we'd also like to add in sort of time variation. So you can see over time, has your area become better or worse for bees over the last 10 years or so?
Wow. So if I'm really interested in BeeScape and I have an apiary, I can feed my information back into BeeScape and actually help make it better for future users who will be able to get that information from whether my hive survived or not.
Exactly. So we're hoping this will serve as sort of a citizen science and citizen science partnership platform, so that we can get this really sort of localized information about how beehives are doing at these specific locations. And of course, all of this, all the data that's people provide is private, and we will not share it with anyone. But we can use it to improve our models and hopefully provide better tools for beekeepers.
First of all, do you have a pollinator book recommendation for our listeners?
So, my sort of go-to book that I always recommend to new students who are coming in is The Biology of the Honeybee from Mark Winston, which is an oldie but a goodie. And I love it because it really is very integrative, and it goes from sort of the evolutionary history of the bees to their physiology and behavior, and also their management. So I really think it's a great overview that provides really excellent introduction into sort of the beautiful world of bees.
That's awesome. And it has a lot of really beautiful diagrams in it as well. I'm a big fan of that for sure. Okay, what's your go-to tool for working with pollinators?
So I think the most important thing that anyone needs with working with pollinators or with beekeepers or growers or anyone is really curiosity, right? So I cannot tell you how many times, some experiment that we have set up, we expected it to go in a certain way, and the data is coming back and it's not going that way. And sort of probing into that more, we would find some really, really interesting outcomes that provide insights that we weren't expecting. And the same thing, from sort of our sort of outreach and education opportunities where we're talking with different stakeholders. I've learned so much, from those conversations and the insights of people who are actually, again, working directly with bees or working with crops and the suggestions that they have. And that's inspired, again, a lot of our research. So I think just sort of having the curiosity to follow up on these things that you either see or hear or are told is really important.
Perfect. And then our final question for you is, what is your favorite pollinator species?
So I honeybees, I have to say. Even though I appreciate all bees and some of them have really interesting characteristics and are very important for pollination services. I just, that was sort of my first love is honeybees, and there's just always so much that you can learn from them. So I will put in a plug for honeybees.
That's excellent. Well, thank you so much for speaking with us today. It's been really great to have you. And we're really excited about BeeScape and its new expansion that just brought it to all the states, including Oregon. So thank you.
All right. Thank you very much, Emily.
Thank you so much for listening. The show is produced by Quinn Sin and Neal, who's a student here at OSU in the New Media Communications program, and the show wouldn't even be possible without the support of the Oregon Legislature, the Foundation for Food and Agricultural Research, and Western SARE. Show notes with links mentioned on each episode are available on the website, which is at pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's several ways to connect with me. The first one is you can visit the website and leave an episode-specific comment. You can suggest a future guest or topic, or ask a question that could be featured in a future episode. But you can do the same things on Twitter, Instagram, or Facebook by visiting the Oregon Bee Project. Thanks so much for listening, and see you next week.